Example 10. Expressing the equation of a circle as a function. Does the equation x squared plus y squared equal 1 represent a function with x as input and y as output? If so, we're going to express the relationship as a function y is equal to f of x. So the equation of the circle x squared plus y squared equals 1, what we want to do is we want to isolate the y. So we're going to subtract x squared to both sides. So we get y squared, which is equal to 1 minus x squared. Now what we want to do is we want to be able to solve for y. In order to solve for y, we need to take the square root of both sides. When we take the square root of y squared, we get y. When we take the square root of the other side, we're going to get a plus and minus according to the definition of the square root property. So we get plus or minus the square root of 1 minus x squared. So that means you have two solutions. You have negative square root of 1 minus x squared and positive the square root of 1 minus x squared. So in this scenario, we're going to get two outputs corresponding to the same input. So this relationship cannot be represented as a single function, y equals f of x. And if we graph both functions on a graphing calculator, we will get the upper and lower semicircles. So are there relationships expressed by an equation that do represent a function, but that still cannot be represented by an algebraic formula? Well, yes, this can happen. For example, given the equation x, which is equal to y plus 2 to the power of y, if we want to express y as a function of x, there is no simple algebraic formula involving only x that equals y. However, each x does determine a unique value for y. And there are mathematical procedures by which y can be found to any desired accuracy. In this case, we say that the equation gives an implicit and implied rule for y as a function of x, even though the formula cannot be written explicitly.